before we go, let's just start out with this. I got about 5 minutes worth of things we can talk about this particular type of reaction right here. Okay? The rest of this chapter pretty much will be spent talking about types of reactions and learning how to predict what products are formed and learning how to write equations for them. Okay? So just practice with that sort of stuff. So the first type of reaction we'll start with is called double displacement. It's where two ionic reactants swap their ions. So these two reactants are ionic, okay? Because in this case we've got silver, and silver was one of those fixed charge transition metals. Anybody remember what charge silver has? Silver is single plus, and nitrate is 1 minus. Sodium is plus, iodide 1 minus. Okay. So ion pairs. So probably on the quiz I will ask you to write ion pairs, or I will ask you what the cation and what the anion are in each of the components, right? All we're talking about is this is the entire compound, but these are the two ions that it's made out of. It's made out of the Ag plus ion and the NO3 minus ion. This is made out of the Na plus ion and the I minus ion. Okay? So we identify them as ionic because in this case we've got a metal and a nonmetal. In this case we've got a metal and a polyatomic ion. Okay? Those are all ways of making ionic compounds. We don't have anything molecular. What are molecular compounds made out of? What only? Nonmetals only. So if we had H2O or something like here that's made out of only nonmetals, that wouldn't work with this. Okay? So we have to have two ionic reactants. So the first thing we do is we write the ion pairs for the reactants. Okay? And now what we're going to do to predict the possible products, I'm going to swap those ions. So if these are the 4 ions that we have to work with, and silver paired with nitrate in the reactant, what other ion would silver be able to pair with here to make a different product? Yeah, silver would be able to pair with iodide. Let's make that ion pair, silver plus I minus. Okay. How come silver could not pair with sodium? Because they're both positive. They're both metals. Okay. We have to make plus minus ion pairs. Okay. So then what would the other ion pair start with? Yeah, it would start with sodium and pair with nitrate. Ionic compounds always have the plus, then the minus. Okay. So like this, the metal, then the nonmetal. Here's the metal. Here's the polyatomic ion. Okay. So those are the new ion pairs. And then what we do is write the formulas from those. And these ones are pretty easy because what formula could I write from silver plus and I minus? That's pretty simple, right? It's just AgI. But again, let's leave room for a coefficient, formula, phase label. We don't know its phase label yet. Coefficient, NaNO3, phase label. But NaNO3 was the new compound formed from that ion pair there. Okay. So then we would balance if necessary. Is it necessary in this one? 1 silver, 1 silver, 1 nitrate, 1 nitrate, 1 sodium, 1 iodide, balanced. Okay. That one's already balanced. What I'm going to show you here, though, and maybe next time if I get a chance I'll bring a big version of this for you to actually see. This is what this reaction looks like. Okay? We've got aqueous reactants, but when they meet each other, there is a solid product. If both of those products were aqueous, then we'd have things that just stayed dissolved. But that plume of stuff that you can actually see, that's what happens when one of the products you form is solid instead of aqueous. Okay? So what we're going to do at the start next time is use solubility rules just from a compound to be able to predict whether it forms an aqueous product or a solid product. Okay? And that'll tell us whether or not a reaction happens and what their phase labels are. Okay? So have a nice break, everybody. Take care.